Hey, slightly different one from me today. We're going to look at something I actually built rather than just talk about general concepts around building things. I'm going to do a series of these. These, as you probably gleaned from the title, are focused around the advent of code 2023. I happen to do them in Rust. This isn't a programming tutorial about Rust, but we're going to work through the 18 days that I did do, talk about how I solved the problems, how I thought about them, and really focus on how I was thinking around trying to make code that's clear and understandable with the goal that, should somebody ever pick up this code base in the future, they could work on it without too much complication. These aren't always the fastest solutions or the fewest lines of code or anything like that, but that wasn't really the point. My goal here was to create something potentially educational. But look, without further ado, let's get stuck into Advent of Code. So here we are on the Advent of Code website. You can see I got a red hot 34 stars over December. I stopped at the end of December, had to head back to work and some other things I wanted to work on, but fairly good progress. You'll see here there's a couple of days where I only got 1 star. But look, let's jump right in. Day one was, and I'm not going to go into the story of Advent of Code. High level TLDR is there's no snow and we want to get the snow back. Each day you're given a programming problem and you solve it. And if you do, then you get a star. There's 2 parts to each question, usually an easy version and a slightly harder version. We'll start with day one. Day one's pretty simple. It's just really meant to warm you up and get you into the spirit of solving problems over Christmas. But anyway, so the problem here looked at these strings. So they were 1 per line, and they were a mix of lowercase characters and the digits 0 to 9. And the goal of part 1 was to find the leftmost digit and the rightmost digit, so 1 and 2 in this top example, combine them together into a 2-digit number, in this case 12, and do that across every row in the file and sum all of those 2-digit numbers together, which, spoilers, if you did that for part 1, you got 55538. So this is what the part 1 input looked like. Zooming in a little bit here, you can see there's just like hundreds upon hundreds, I don't know how many lines there are, probably thousands, of these strings. There's some easy ones, a 2 and a 3. There's some like this example where you'd get a 7 from the left and the right, and there's plenty more through here. But let's dive straight into how I looked at the solution by jumping over to the terminal. So this is my day1.rs file. There's 2 functions in here. It's a pretty simple one for day 1. We've got day 1, the main function that gets run in our main file, and then we've got a function above which we'll go into, which is mainly around part 2. So as with many of these problems, the first few lines, up to line 51 here, that's all about opening the file, reading its contents, and getting ready to loop through it. We store a value to accumulate the total of all these checksums, nothing too crazy there. Loop through each line. This is all part 2 related code, which we'll get to. But starting from about here, what we do is we loop through the characters in the string. We check if those characters are numeric, looping left to right, that is. If they are, we convert it to a digit, to a number in base 10, and store that in our variable current. Now, because the first digit we find left to right is the tens digit in our final checksum, we multiply it all by 10. Some more stuff with part 2, which we'll get to. And then we do the same thing, but we reverse all the characters, which means that we loop through from right to left, find the first numeric value, add it to our current value, and then add it to our total. This one's pretty simple, as you would expect for part 1 of day 1. Just loop through, accumulate values, check if after checking if they're a digit. Going back to part 2, though, this is where things start to get a little bit more interesting. So the adjustment in part 2 is that some lines in the file, they have the numbers spelled out as letters. So in this case, you can see I've highlighted TWO, which is 2, NINE, which is 9. The part 1 solution for this line would be 11, because it would be 1 from the left, 1 from the right. But with this adjustment for part 2, we need a 2 and a 9 to make 29. So what do we need to change to make this happen? This is where our find earliest replace function comes in. We'll jump back up to that one. The way that works is it takes the line that we're processing and a flag to say, are we looking from the left? Or if it's true, are we looking from the right? And it returns a string. So the way I set about doing this was I said, okay, if we take ONE, TWO, any of these digits spelled out, simply find and replace the first one with the numeric equivalent, then we can use the rest of our code without making any changes to it. So how do we do that? If we're moving left to right, we loop through each of the digits, and if we find a match for that digit, so ONE appears within the string, we store the position and which value matched, assuming that it's an earlier match than any of our previous matches. So we go through 1, 2, 3, 4, all the way up to 9 and do that. And if we don't find a match, we just return. We don't make any modifications. And then if we do find a match down here, we'll talk about rev in a second, we replace 1, ONE, with the digit 1, and so on, depending on what match we found. And then in this case, let's say we had that string from before, ONE, and let's say we had a 3 and then a FIVE. This function, as it was, would modify the string to be 1, 3, FIVE. It only changes the first replacement, but that'll get us through finding from the left. Now, the other variable here that you can pass in, the other argument to this function, is this rev reverse variable. That one, if you pass it in, it does a couple of things. It reverses the input line. So if we had that example from before, 5, first it'll reverse it to EVIF3ENO, and then it will also, as it's going through checking each of the digits, reverse those digits. So 1 will be ENO, 2 will be OWT, and so on and so forth. And it still does that same left to right match, stores the earliest match that it can find, as well as the position of that earliest match. So in this case, when reversed, the earliest match is going to be EVIF, which is 5 backwards. Now, this probably falls into like the first point where this is a bit of a hack. It's a neat trick. I was kind of chuffed with myself when I realized you could do this. I originally was going to use a string index and move left and move right, but it turns out if you reverse both, you can use the same code. This is not the kind of thing I would put in a production code base. Yeah, I could litter this with comments and examples to explain how it works, but it just adds a bit of extra thinking that I don't think is necessary to solve the problem. But it was Christmas, silly season, so I left in some silly code. The other adjustment down here, if it's reversed, you reverse the input line, you then reverse the digit, and then you do the find and replace, and you reverse everything again, and then you return it. So coming back down to our day 1 function, you can see if we're in part 2, we take our line, we do our replacement, and pop it in the vline variable to do our exactly the same, check for a numeric character and store it. And similarly, in the second half, part 2, we do this with vline B. We do the replacement, this time with reverse being true, and then we store it in vline and do the check. Now, if you're wondering why I did this replacement twice into 2 different variables and didn't just replace left, replace right, that's because in some of the examples, you might have this. So if you look left to right here, this ONE EIGHT should be 1 IGHT from the left, and coming from the right, it should be 8. So if you do these replacements independently, the checksum of this string is going to be 18, as it should be. But when I initially ran through this, I just did both replacements at once. The first replacement took ONE EIGHT to 1 IGHT, and then the second replacement couldn't find any matches, so the final string was 1 IGHT, and then looking left to right in that string, we'd get the checksum 11. So this tripped me up for a little while. I had to dig through a few examples, scroll through the input file that they gave us to work out exactly why I wasn't getting the match that I wanted there. But with that out the way, we made our submission for part 2, and it was 54875, second gold star, and that was day 1 complete on the calendar. So hopefully that was interesting. If you're enjoying this sort of content, do let me know in the comments or consider subscribing. I'm going to make 18 videos here, one for each of the days that I completed. This one's a quick one because it's day 1. Some of the others may go on a little longer, require a little bit of extra information. But as always, I'm Elliot. I build stuff, and thank you for tuning in.